Hey everyone, welcome back to the channel. Today's project is for anyone who's building RAG systems. One question that always comes up is, what chunk size should I use when splitting my documents? Most people just pick a number and hope for the best. But today, we're actually going to test it and measure it. We'll use a technique called HyDE for smarter retrieval, and then use GPT-4 as a judge to score our results. So by the end, you'll know exactly which chunk size works best for your document. Let's get into it. The idea is simple. When you build a RAG system, you take a big document, cut it into small pieces called chunks, and store them in a vector database. When someone asks a question, you find the most relevant chunks and give them to the LLM. Now the problem is, chunk size affects everything. Too small, you lose context. Too big, retrieval gets messy. So in this project, we test multiple chunk sizes on the same document and score which one gives the best answers. Simple as that. Normally, you embed the user's question and search the vector database. But a question and an answer look very different in embedding space. HyDE fixes this. Instead of embedding the question directly, it first generates a fake hypothetical answer using an LLM. Then it embeds that. Why? Because a fake answer is much closer to the real document chunks. So retrieval becomes more accurate. That's HyDE. Simple idea, big improvement. Now, let me walk you through the full workflow of this project. Step 1, mount Google Drive. Step 2, install libraries. Step 3, API key setup. Step 4, load the document. Step 5, split into chunks. Step 6, generate test questions. Step 7, HyDE retrieval. Step 8, GPT-4 evaluation. Step 9, collect and compare results. Step 10, final data frame. If you're building a RAG system for real use, this matters a lot. Bad chunk size equals bad retrieval equals bad answers. And the scary part is your LLM looks fine. Your prompts look fine. But silently, retrieval is failing. This project gives you a way to catch that with actual numbers. All right, concept clear. Now let's open the notebook and start building this step by step. Mount Google Drive. First, we connect Google Colab to our Google Drive. Our document is stored there, so we need this before anything else. After running this, you'll see mounted at Content Drive. That means Drive is connected and we can access our files. Install required libraries. Now we install all the packages we need. LlamaIndex is our RAG framework, Anthropic is for Claude, and HuggingFace gives us our embedding model. Lots of lines will run. That's normal. No red errors at the end means everything installed successfully. Upgrade LlamaIndex. This line upgrades LlamaIndex to the latest version. We run this separately to make sure everything is fully up to date before we start building. No errors means the upgrade went through fine. Now we're running the latest stable version of LlamaIndex. Import libraries. Now we import everything into memory. We're bringing in LlamaIndex tools for indexing, evaluation, and querying, plus pandas for our final results table. Libraries imported successfully. All good. We're ready to start building the pipeline. Claude API key setup. Here we set our Claude API key. This is what authenticates us with Anthropic, so we can use Claude as our LLM throughout the project. Claude API key configured. Claude is connected and ready to use. Configure LLM and embeddings. Now we load two models, Claude Haiku as our LLM for fast responses and BGE from HuggingFace as our embedding model to convert text into vectors. Claude LLM plus HuggingFace embeddings setup completed. Both models are ready and set as defaults for LlamaIndex. Load documents. Here we load our actual document from Google Drive. We just point LlamaIndex to the folder and it reads everything automatically, PDFs, text files, whatever is in there. Loaded X documents. That number shows how many pages or files were read. This is our knowledge base for the whole evaluation. Generate evaluation questions. Instead of writing test questions manually, we let Claude generate them automatically from the document. We take the first 20 pages, generate 1 question per chunk, then randomly pick 10 for testing. There's also a retry system built in, so if Claude hits a rate limit, it waits and tries again automatically. Generated 10 evaluation questions. These are real, document-based questions we'll use to benchmark each chunk size. Okay guys, so we've covered the core setup of this project. From mounting Drive, installing libraries, loading documents, configuring Claude, all the way to setting up our evaluation system with the faithfulness evaluator. Now the remaining blocks, the relevancy evaluator, the core evaluation function, running all chunk sizes, and the final results table. I'm not covering those in this video, but don't worry, everything is available for you. To get the complete code dataset and run it live in the browser, check the link in the comment section. It's from Aionlinecourse. Everything is there, coding playground, resources, all in one place. If you learned something today, hit the like button. Subscribe for more projects like this. See you in the next video.